So last class we talked about albedo and kind of related how it's connected to the greenhouse effect. So we get all of our all of our radiation from the sun. It can be absorbed by land and oceans, about 51% approximately. It can also, then the ocean and land can release radiation back into the atmosphere. Some is radiated directly to space, and some is absorbed by the atmosphere, about 15% of what is reflected or released back into the atmosphere. Some can be carried to the clouds by latent heat in the water vapor, about 23%. So as it heats up the ocean, it turns the liquid water into vapor and goes into the atmosphere and turns into clouds. So 6% is reflected into space by the atmosphere when it hits our atmosphere. Then when it hits clouds, 20% is reflected. And then when it hits the Earth's surface, only 4% is reflected. 3% of that is also absorbed by the clouds. Conduction and rising air gives off 7% radiation. And about 64% of the radiation that's reflected from Earth is radiated to space from the clouds and atmosphere. Okay. The rest stays on the planet and warms us, keeps us warm. So we're going to watch a quick video while we're watching that. See if you can use it to help you also summarize how albedo is connected to greenhouse, the greenhouse effect.
Everyone knows that Earth gets light energy and heat energy from the sun, but what happens to this energy? Some of the energy gets absorbed by the atmosphere, oceans, the land, but some of it gets reflected back to space. Sounds complicated, doesn't it? Let's talk to Patrick Taylor from NASA to find out what Earth's energy balance is all about.
Earth's energy balance is really that. It's just a balance between the amount of energy that's coming in and the amount of energy that's leaving the Earth. So balancing Earth's energy budget is a lot like balancing an equation, where let's say X is incoming energy, and that has to equal Y, which is outgoing energy. So when these two are equal, then we say Earth's energy is in balance. So energy from the sun comes to us in the form of light, and it's also known as radiation. It can be absorbed in the atmosphere. It can also then be reflected back to space, either by the clouds or by the polar ice caps, a very bright surface. The third thing that can happen to it is it can be absorbed by the surface. A total of 70% of the energy is actually absorbed in the Earth system, and only 30% is reflected back to space. Small changes in Earth's energy balance can have very big impacts on Earth's climate, changing the frequency of heat waves and cold waves, the frequency of hurricanes, as well as our ability to farm, the availability of fresh water and clean air, impacting human health. So we've been studying Earth's energy balance for more than 40 years, including the Nimbus 7 satellite, the Earth radiation budget experiment in the mid-1980s, and also since the late 1990s with the launch of CERES, which is Clouds and Earth's Radiant Energy Instrument. And that's actually the science team that I'm a part of. So to understand what controls Earth's energy balance, we also observe a lot of other different types of information. Having a steady supply of data is really important, especially for studying Earth's energy balance. The small changes in Earth's energy balance make a really big impact on Earth's climate. And having a long data record is really important for assessing those changes. Earth's energy budget is essentially adding up all of the terms. But when Earth's energy budget equals zero, so if we have incoming energy plus outgoing energy, and they equal zero, or they balance each other, that's when you have Earth's energy balance.
More energy coming in than what you give off, and the system will heat up. More energy going out than coming in, and the system will cool down. Planet Earth with its atmosphere has just the right balance for life to thrive. And that's what makes Earth a great place to live, no matter what the weather. Hey, here comes the sun. See you next time on Real World.
So kind of what she summarized at the end, if more is reflected than absorbed, it cools down the planet. And if more is absorbed than reflected, it heats it up, like the greenhouse effect. Heats it up, keeps us warm. So the greenhouse effect is good because we don't look like Pluto, but it can be bad if it is too hot. Okay? So you can come to office hours Thursday after school. My fifth period, Mr. Shumnu's fifth period, or Mr. Roman's fifth period. So we're going to watch 2 more videos about the greenhouse effect. I'm going to pause. I don't want them to run out. I don't want this video to run out. And then I will explain what you're going to do for your claim evidence reasoning paragraphs as part of your assessment.